Okay, right now I'm going to talk about algebraic expressions. So title your paper 1.2 Algebraic Expressions, and then write today's date right in the top right corner. You guys know a lot of these type of terms for algebraic expressions. We're going to talk about how do we go from the English language to math language, and what does that look like? You know a lot of these, so we're just going to review them real quick. So we're going to do that by making a table. And our table is going to look like, straighter than that. Our table, you know what, I'll make bars for this. Our table will look like this. And over here, let's put all of our different operations. So let's start with addition. Well, what are all the different ways we could say addition? The first one, I would say, is add, right? Add's easy. Then we can say sum. And the sum is the answer to an addition problem. And then we can say more than. And over here, so these will be the words. Over here, we'll put the expression. Like, what would this look like? This is n add 5. Okay, it could be the sum of n and 5, add n and 5, n plus 5, n 5 more than n, and so on. The next one is going to be subtraction. Now this one gets a bit tricky because order really matters here. Now subtract, obviously. And we have difference. That's the answer to a subtraction problem. And we have less than. This is the one that throws everybody off, and I'll show you why in a second. So if we have this expression over here, this is x subtract 11, or x subtracted by 11, or the difference between x and 11. Now, here's where it gets tricky. When we see less than, that is 11 less than x. Because if you have less of something, it has to go second. Like if I had $10 and Steve had $8, and you did, Steve has less dollars than me, it's going to be 10 minus 8. So less than flips the order. 11 less than x, or less than a number. All right, let's move on. Hopefully that made sense. Now, let's look at multiplication. And I'm going to use this because we're big boys and girls and we use multiplication like that. We use that symbol. Now, you probably know what most of these are. Multiplied times, if you're in elementary school, 3 times 5. Or product. And product is the answer to a multiplication problem. Now, what does that look like? It looks like a lot of things. It could look like this, 3 multiplied by m. It could also look like this, 3 times m. Or like this, 3 with a parentheses m. All multiplication. And that doesn't matter what order it's in. But this, division, definitely does. So, what are all the words for division? Well, you could say divided by, divided into, and then quotient. Now, divided by is easy, right? If I were to put a divided by 7, that's what it would look like. A divided by 7. Now, when we get to divided into actually looks like that would be 7 divided into a. Into flips it just like less than flips it. So be aware of that. Now, quotient is just like product, just like difference, just like sum. It's the answer to a division problem. So this would be the quotient of a and 7, or the quotient of a number and 7. All right, so get this table. And it could also look like this over here. It could look like a divided by 7. All right, so you guys know that stuff. Now, let's move on. Write an algebraic expression for each word phrase. So here we have a word sentence. We need to turn it into an algebraic expression. 1 more than the product of 12 and p. So what is more than? Well, if we look back on our chart, more than is addition. So 1 more than, and you could put it up here, that'll help you, the product of 12 and p. The product is multiplication, 12 and p looks like this. So 1 more than the product of 12 and p. So it could be 1 plus 12p. And if you put a multiplication symbol in there, that's fine. Well, what about this? 4 less than a number n divided by 2. Now, if you look here, less than, remember, it flips it. 4 less than a number n divided by 2. So we need to do this second part first. Let's look at this. A number n divided by 2. I'm going to write it like this, like a fraction, because we know all fractions are actually division problems. So n divided by 2, and it's 4 less than that. So n divided by 2, minus 4. Just like that. 4 less than, subtraction, a number n divided by 2. Okay, moving on. I want you to try these on your own. So you can pause now and try those. Okay, welcome back. 9 less than a number. We know that less than is subtraction. Whenever we see this phrase, a number, that could be any variable. It could be n or x or t or y, whatever you want. So 9 less than a number. Less than flips it, so we're going to go n minus 9. Now what about this? 3 increased by. Increased by, addition, the difference of p and 5. So this kind of looks strange. 3 increased by the difference of p and 5. Well, 3 increased by. Now if it's the difference of p and 5, we need to put those together. The whole difference of p and 5. So 3 plus the difference of p and 5 looks like this, p minus 5. 3 increased by the difference of p minus 5. Because if we just would have kept it like this, this would have been 3 plus 5 minus 3 plus p minus 5, and that wouldn't have worked. So that can't work. It has to be 3 increased by the whole difference of p and 5. Okay. Now, we have to write a word phrase for this. So we have to go from math to words. And there's a lot of different ways to do this. We have 4, right? So we could just put the number 4. We could put the word 4 subtracted by 7 times b. It could be that easy. We could also say the difference of 4 and the product of 7 and b. There's a lot of different ways to do it, as long as you're using that right language in the right order. You could say 7 times b, sorry, not that. Oh, sorry, 7 times b less than 4, because remember, less than flips it. So any of those work. All right. So you get the idea. You have to change from algebraic expressions to words. And the easiest way to do it is just, if you were to tell your friend what the problem was, what would it look like? Or what would you say? And that's what you could do. So try this one on your own. Now, this one, I'm going to type these out, could be 9 minus 3 times c. That easy. Or a number. You could also say the difference of 9 and 3 times a number. Or you could say 3 times c less than 9. Any number of those work. And you could have one that's not even on there, but you know it could work. All right. So hopefully you got one of those, or something close. Moving on. What does this look like with word problems? Well, Don't write this whole thing down, but some important information. A company aired its 30-second commercial N times during the Super Bowl. So N times, the reason we use a variable there is so that we can change whatever we want in it. So a company aired its 30-second commercial N times during Super Bowl 39. Yes, that's each X is a 10. And then IX is 9 because this is 10. The one before it's a minus. At a cost of $2.4 million each time. $2.4 million per 30-second commercial. And they had N of them. Now, write an algebraic expression to evaluate what the cost would be if the commercial had aired 2, 3, or 4 times. Well, if it's $2.4 million every time and you did it once, that's $2.4 million. If you did it twice, $2.4 million times 2. If you did it 3 times, $2.4 million times 3, and so on. So I'm going to use 2.4 times n. And we're going to make a table because it's going to be really easy then to organize what we have. So here's my n's. So we have 2, looking up here, we have 2, 3, and 4. And let's see how much they cost. So 2.4 times 2. Double 2, that's 4. Double 4, that's 8. So it's going to be $4.8 million. So we'll put that money in millions. All right. This, we have 2.4 times 3. And if you think about it, let's do this real quick. Well, let's triple the 0.4, that's 1.2. Let's triple the 2, that's 6. 1.2 plus 6 is 7.2 million. Now let's do this. 2.4 times 4. Well, 2.5 times 4 is 10. Take back 0.1 times 4, which is 0.4, so it's going to be $9.6 million. All right. So that's exactly what you do. We took a word problem, made an expression out of it, and figured it out. Now, I want you to try this one on your own. Okay, so a restaurant leased its banquet hall for a function. The cost was $10 per person. So write an algebraic expression to evaluate the cost it would be if you had 20, 21, 22, or 23 people attending the function. So if it's $10 per person, if you had 1 person, it'd be 10. If you had 2 people, 10 times 2, it'd be 20. If you had 3 people, 30, and so on. But what if we had n people? Well, we have 10n. That would be the algebraic expression. Now, let's put it in a table. And hopefully you did this. And our n's would be 20, 21, 22, or 23. Now, remember, and this would be cost, we'll say, in dollars. So if I did this, 10 times 20, whenever you multiply anything times 10, you just add a 0 to it. So 20 times 10 is 200. 10 times 21, add a 0 to it, it's 210, and that's costs in dollars up there. 10 times 22 is 220. 10 times 23 is 230. And there you go. We just went from words, okay, up here, to an algebraic function, to filling in the table. All right, hope this was helpful.